Okay, in this video, what I'm going to do is I will talk about uh, uh, subnetting a Class C network. Okay, so we're going to subnet a Class C network. And as you know, a Class C network has an, an N equal to 24. So 24 of the bits are fixed in that network and we can't change them. But the last 8 bits we can use to break up our network into subnets. And S plus H has to equal 32 minus 24, or 8 in this case. Okay, and I put a dotted line here at the division between S and H because we can vary that. Okay, and so there's a lot of ways we can do it, and you can work purely mathematically, or you can sort of imagine breaking it up in factors of 2. So what I'll do is I'll first say that we have the number of addresses is 2 to the 8th, or 256, that we have to work with. And we can break these up however we want. If S were 1, then we'd only have 2 subnets, and each would have 128 addresses. So we could say that let me draw a picture to help with this explanation. So I'm going to draw this range of IP addresses here, across here. And there's 256 IP addresses across here now. And I can take that and I can divide them into 2 pieces. And I can use 1 bit, that is S equals 1. And I can use 1 bit to distinguish between the left side and the right side. S equal, that bit could be either 0 or a 1. Okay? If I take S equal to 2, then I've got 2 bits for my subnets, and I've got 4 of them, 2 squared. Okay? If S is 3, then I'm going to break it up into 8 pieces. 2 to the 3rd is 8. If S is 4, then I'm going to break it up into 16 pieces. So I have all the previous divisions, and I cut it in half once more. And this is going to give me 16 IP addresses. Okay, and finally, if I use, let's see, this is 1 bit, 2, 3, 4. If I use 5 bits for my subnet mask, then I'm going to take each of these and divide them into 2. Maybe I won't complete that drawing, but I'll then label this as, let's see, if we've used 5 bits for our subnet mask, I've only got 3 left over for the host addresses. 2 to the 3rd is 8th, and so I've got 8 IP addresses in this smallest little division down here at the lowest level. Okay? And so here we have 256 addresses available, which is 2 to the 32 minus 24. Okay, and that's 2 to the 8th. So this is taking the Class C and not even really subnetting it. We've got all of them into 1. And we have S equals 0. Let's make a little chart here for S and H. S is 0. H is 8. All 8 of the bits are being used for these 256. Okay? And as you know, we use the slash notation and we have a slash, and then an n plus s is the value we put after the slash. And here, n is 24 and s is 0, so this is a slash 24. Okay, so we haven't subnetted that class C at all. Now if we use 1 bit for S and 7 bits for H, I have 128 addresses per subnet, and that's 2 to the 32 minus 25, or 2 to the 7th. And it's the slash 25 then. The 24 plus 1, n plus s is 24 plus 1, or slash 25 network. And the pattern continues. We have 64 addresses here, which is 2 to the 32 minus 26, or 2 to the 6th. S is 2 here, and H is 8. And when H is 8, we have 2 to the 6th, or 64 addresses. This is a slash 26. Pattern continues. We have a slash 27, and a slash 28, a slash 29 network. In the slash 27, we have 32 addresses per subnet. In the slash 28, we have 16 addresses per subnet. In the slash 29, we have 8 addresses per subnet. And if I complete the chart, 3 and 5, 4 and 4, 5 and 3 now. And here, 8 is 2 to the 32 minus 29, or 2 cubed. 16 is 2 to the 32 minus 28, or 2 to the 4th. 32 is 2 to the 32 minus 27, or 2 to the 5th. Okay? So I encourage you to reproduce this page on your own. Get out a blank piece of paper and talk yourself through this. And the reason I'm making these calculations over here is that this shows you how to take the subnet number, the slash number, say a slash 26. You want to know how many IP addresses are in a slash 26 network. You go 2 to the 32 minus 26, and that gives you the number of IP addresses in that subnet. Okay, so this is basically the way that you could subnet a class C network. I guess we could continue on with a slash 30, and that would have 2 to the 32 minus 30, or 2 squared, which is just 4 IP addresses. And recalling that 2 of the IP addresses in a subnet are always used for the subnet ID and for the broadcast address, we would have 2 to the 32 minus 30 minus 2 host addresses available, which is 2 to the 2 squared minus 2, which is 4 minus 2, or 2 host addresses available. Okay, and sometimes we use a slash 30 network when we want to create a subnet between 2 router interfaces, for example. We only need 2 addresses, a point-to-point link between 2 router interfaces. We'll use a slash 30. A slash 31 makes no sense because there would be 0 host addresses available. And so these are the most common slash numbers that you're going to see, 24 through 30. Although you can go to lower numbers, which are even larger subnets. So I encourage you to reproduce this page on your own, starting from a blank piece of paper. Good luck.